So here we have a graph that doesn't match any of the four that we've seen, but this in fact makes the question easier. Because the very first step that you'll always have to do is draw your base graph or your parent graph. So if you were graphing x cubed minus 5, you'd first have to think, I know what my x cubed graph looks like, and the minus 5 would move it down 5. For these ones, they give you some obscure graph, and it's given to you, so you don't have to do that. This is our starting point, the graph of g of x. All we have to do now is sketch the image after each translation, write an equation, and state the domain and range. So for the first one in part A, we want to move it 4 units to the left. So all we're going to do is we're going to take each of these key points. So there's a key point there. I'm just going to move that 1, 2, 3, 4 to the left. And I'm going to do that with each of these key points. And then you get to do something fun you probably haven't done in school since, I don't know, grade 2 or 3. Connect the dots. So much fun. And connecting the dots in the right order is important, right? Because if I connect these dots in the wrong order, it's not going to look like my graph that I began with. So here we go. Connect the dots. There's our graph after moving 4 to the left. I did that one in blue. So off to the side here, I'm going to write part A because it asked us to write the equation in terms of g. I'm going to highlight that because one of the things that is difficult in math is getting used to the language. I was a student. I know that when you're a student, there's certain times during class you go, okay, the teacher's just talking about not important stuff. I don't have to pay attention. For example, you probably didn't listen very much while I read the question. Because you're like, it's written down. I can read it later if I want. So I don't listen while a teacher, well, I kind of listen, but I kind of go, this isn't an important part. If I've got 25 minutes this morning where I can really concentrate, that's my maximum, I know that this is a good time to take a break. And you do that all the time. But the problem is sometimes you miss key things. And the key things that you miss is the language in a question. Has it ever happened that you felt like you knew how to do everything in class and you got to a quiz or a test and you read a question and you go, oh, I don't know where to start? Now, that's mainly because you didn't pay attention to the language in the question when it was taught, and this is one of those things. This, in terms of the function g, in terms of x, comes up a fair bit in math. So what does it mean? It means that we need to write an equation that has g in it. So it's going to be y equals, and g is going to be on the other side somewhere. So in terms of means that you have to have that in your equation somewhere. Now, if we look at this, how do we write something being moved 4 to the left? Will it be inside the function or outside of the function? Inside of the function. So we know that something's going to happen inside of g. And because it was moved 4 to the left, everything inside we've already seen has been opposite. So there is our inside function. And that is writing that equation in terms of g. So our new graph is y equals, and it's the old graph being moved 4 to the left. The equation also said, can you find the domain and the range for your blue graph? So here you get a choice. You can write things with set notation or with interval notation. Can you see that domain, that's your x values. So when you're looking at a graph like this, one thing I always look for is, can I see my lowest x value? It's -5. And it includes everything from -5 until you get to your maximum x value, which is 2. So how do we write that down? In set notation, if x is between two numbers, we write it like that. X is between -5 and 2, so the domain is -5 is less than or equal to x is less than or equal to 2. In interval notation, an interval means it starts at one point, ends at another point. So what's our starting point from the left? The smallest value is -5. We use a square bracket to show that that -5 value is included. That square bracket is the same as the equal sign under the inequality. And it goes all the way to 2, also included, so there's square brackets on both sides. The range are your y values. Again, think about coming from the bottom, what's my smallest y value? It's 2. And then it includes everything all the way up until you get to 5. So in set notation, you'd write it like this. In interval notation, it would go from 2 to 5. Now, one idea that's sometimes used for domain and range is a flashlight idea. If you took a flashlight from above this graph and shone it straight down, can you see that? Let's see, what kind of pen should I use? Yeah, this one looks ugly. Yeah, there we go. Can you see that that's the shadow that would be made? If flashlight was shining down onto it, and that's what the domain is asking for. It doesn't matter how much it goes up and down, it's just asking which x values were included. And all of them from -5 to 2 were included. Now, with the flashlight for the y value, again, you do it from the side. With the x values, you do it from up above and below. But you have to sort of do it from both sides. Because if I shone the flashlight from this side, well, it would only go up to there, right? But if I shone the flashlight from that side, there would be a shadow all the way up to there. So again, you're thinking about what are the y values that are included, what are the x values that are included. That's your domain and your range. How do you remember that domain goes with x and range goes with y? Do you have they're not natural words that fit with that probably. So when you first learned it, how did you remember?
Domain, like a kingdom domain.
Oh, the land, okay. And range is like? You just did the domain part, okay. Anybody else have memorization strategies? Some people say, well, x comes before y in the alphabet, and domain comes before range in the alphabet, so I remember it that way. The danger, have you ever used that as a strategy to remember something? The order of the letters? No? Okay. Well, I used it a fair bit, and the problem I find with that is that sometimes it works and sometimes it doesn't, and if you use it too often, then you never remember which ones worked and which ones didn't, and then it doesn't work anymore at all. I had one student who just called it domain and rangey. They added a y to the end of the word range, and they've never forgotten. I said, do you add an x on the end of domain? Domainx? No, they just did rangey. Define the rangey. And then they remembered. And it's such a funny word that then all of a sudden you remember it all the time. So if you can do those kind of things as you're going through, they can help you remember. We'll do part B, a translation of one unit up. Again, you take each of the points, the key points, shift them one up, connect the dots, and there we have the graph B. Its domain and range. And what you're going to see me do is I will usually only do one type of notation, interval or set, but I'll mix it up from question to question so you get used to both of them. So in this one, for the domain, the smallest x value is -1. The largest x value is 6. The smallest y value is 3. And the largest y value is 6. Now, after we do each question, so now we've done this question, oh, we haven't written the equation. That's one thing we forgot. So we want to write this equation in terms of g. Will it be inside the function or outside of the function? Outside. So g of x will be just the same, and then we've moved it up 1, so we can show that by adding 1 to the end. So we've done a question. We've got a sense of it. After we've finished a question, what I'm going to do is I am going to tell you which questions in the homework you are now able to do. So above your question, you can write 4, 5, 6, and 7. And then you can turn a couple of pages. And one thing that I find that sometimes students do that's helpful is they then go and circle 4, circle 5, circle 6, circle 7. There are times that I will do 2 questions and then give you some time to work on the ones that you've just circled. Sometimes I'll just give you, we'll just do the 1 question, and that's what we're going to do today. We're just to get used to the book. We're going to do this. We've done this 1 question. Now we're going to go and work on question 4 and 5. And usually I won't give you enough time, unless you're super fast, to finish all 4 of those. But it's just to give you a sense and a feel for how things work. The nice thing about this book, so go to question 4, which is on page 169, and then just turn a couple of pages, and you will see that on page 176, which is where the homework ends, that's where the answers are for that question. So you know how most textbooks you have to flip all the way to the back? I mean, it's better maybe to increase your muscles in your arms, but this is nice. You just have to turn a couple of pages to check your answers, and the answers are there for all of the questions, so you can check along the way, because it's a good thing to do to see if you're doing things right. You'd hate to do all of your homework without checking, just to find out that now you're really good at making the same mistake over and over and over again. You've practiced it, and now you're an expert, so come the quiz, for sure you're going to make that mistake again. That's not what we want to have happen. So we'll take some time to work on those, and then we'll start example 2.